Hi, this video is about how to solve a physics problem and what to show me. Because solving a physics problem isn't just about getting the answer, it's also about communicating your answer with, in this case, me, your instructor, but generally with other scientists who need to see how you did your work. So what we're going to do when we solve the problems is do a drawing, have the known quantities listed, write the equation that you're using, do the math, and by that I mean substitute into the equation the numbers that were actually given in the story problem, manipulate them if need be, and then finally answer it with the proper units. It's not good enough just to say the answer is 12. 12 what? You need to use those units. And as we looked at in the beginning chapter of the book, they were talking about how unit analysis is really important in physics. Sometimes it'll allow us to find the answer or understand what we're looking at when we make sure that the units match with what we want. So units are really important in physics. I'm going to show you an example of student work here, and we'll go through these steps and what I expect when you turn in written work. Okay, so here we have a problem, and you don't see the story problem itself, but you do see the elements that I was talking about. So here the student has done a drawing. Sometimes the drawings are really simple like this. Sometimes they are free body diagrams, which we'll get to in a later video. But that's the drawing part of it. The next component I see here that they've listed is the equation. This is an equation for the Doppler effect, and they have that listed next. Third, they have here a list of, this is the knowns. This is what was given in the problem. This is a two-part problem. So part one, and they've labeled part one to kind of give me a roadmap to what they're doing, shows all of the things that were listed for part one. They've also done the same thing for part two here. So those are the givens, or the known quantities. They've also labeled up here, this is the part of the problem I'm doing. This is the train whistle heard by the switchman, and this is the tower siren heard by the engineer. This is what I consider the math part, where they've taken the equation that they gave me up there in the blue square, and they have put in the numbers, and that way I can see. This one's pretty straightforward. There's not a lot of manipulation, but I can see if somebody made a mistake there. I can always give partial credit if I know exactly what you were doing. And then last, they have the answer, and they've circled it so that I can easily find it, and they've also labeled it. The answer here is in hertz. So all of that's really helpful. Each time you do a story problem, you should have most of these components. Some problems won't lend themselves well to doing a drawing, but most will, and you'll be able to do something. If it's an equation that's not really commonplace, it's nice to write next to here the equation number from the book. In Physics 1, I would say most of our equations are commonplace. But as you go on in physics, there'll be more specialized equations, and it's always nice to have a reference. This is where this information came from. This is where this equation is that I'm using. I hope that helps, and I'll see you online.